All right, so today's agenda. Let me just move people out of the way. All right, so we're going to go through just an overview of these two new courses, who they're for, what they'll cover, and some important info to keep in mind as you think about bringing them to your students. Then we'll take a look exactly where you can access the materials for these, especially the betas that are available now. And then we'll give you some information about our teacher testing group so you can decide if that's something you're interested in joining. And of course, we'll have some time at the end to address any outstanding questions. So to start, let's look at the overviews here. So these are two separate courses. So there's a coding and math course, and there's a coding and science course. We're just kind of presenting them together here. But in general, these courses contain a series of independent standalone modules that use coding to reinforce and extend students' understanding of math and science. As students learn major programming concepts, they'll develop math and science related projects that demonstrate proficiency in both math, science, and computer science topics. So there really is some good programming in some of these. So you'll see that there are various topics presented here. This isn't exhaustive, but just to give you a little bit of spread. And it's also important to note that these are all developed with the Common Core math standards and the next generation science standards in mind. And they're mapped accordingly on the CodeHS platform. So that's a big piece too, knowing that a lot of you do adhere to those standards. These courses were developed with those in mind. So the modules, these independent modules range everywhere from 1 hour to potentially 6 hours long and are designated for either middle school or high school. But depending on where students are, the math class they're in, there's some overlap, and I think there's flexibility there. So most modules are intended for students with very little programming experience, but there are some that are noted in the descriptions that do require prior exposure to some topics. But there's just a couple in there. Most are really aimed for the beginning programmer. All right, so let's look at the module breakdown. So this is the coding and math course. And so in this course, there are 4 new modules at the moment, and that's in the lighter blue section. And they're joining the 3 modules that we had prior to this point, which are in the darker blue. So this webinar, I'm going to talk through the new ones, because some of you might have already experienced the bottom 3, which are currently available in the course catalog. So factors and multiples. This module is designed for middle school students and will probably take around 4 to 6 hours to complete. The premise for this module is that students are helping out at a candy store where they're asked to come up with different options to bag a variety of candies. Of course, what we're really exploring is the nature and usefulness of a number's factors and how to use Python programming to determine those factors quickly. So as you'll see in most of these modules, not only are students learning about or reinforcing their understanding of certain math science concepts, but they'll also be doing some real programming in Python or JavaScript. So the image in the bottom left here is a snippet of the final project that these students would develop, which includes programming concepts of variables, for loops, and conditional statements. So there's a lot going on, and this module steps through it piece by piece, so students are not asked to do all at once, but they're kind of building that incrementally. The next module, the Shapes and Pythagorean Theorem module, has students develop a program for a construction company that will input measurements from a customer and then calculate the dimensions of wood and roofing materials needed. So in doing so, they will demonstrate their understanding of a shape's area and perimeter, along with their ability to use Pythagorean theorem. So this course is also for middle school students and will take around 4 to 6 hours to complete. And you can see a little demo here in the bottom left of a program they'll build, which is getting that user input from the customer and then being able to make the needed calculations and report that back. The next module is the formula solver module. And this is aimed for high school students and will take around 3 to 5 hours to complete. It teaches students about variables, user input, conditional statements, and they learn to build an interactive program that can solve for a chosen variable within a chosen formula. So there's kind of multiple layers of nested conditionals in there. And this module is partially inspired by my first program written as a high schooler, which was a little quadratic formula solver on the TI calculator. So kind of a throwback, but you know, it's both being able to manipulate an algebraic equation and then use the user input to create a program out of that. And finally, we have a vector math module, which is also for high school students. And this has students tackle real-life situations that require a conceptual knowledge of vectors and a practical knowledge of how to work with them. So as we know, they're different than scalar numbers. So students will leverage Python's NumPy library in order to calculate a vector's components and store them in an array for future arithmetic operations. Yeah. Cool. So the coding and science course is very similar. We currently have 2 new modules joining the 3 prior modules. Unfortunately, the 2 new modules are still under development, so will not be part of this early beta access, but I'll talk through them right now. Both of the new ones are aimed for middle school students, but would be appropriate in a high school physics class as well. The bottom 3 are probably more suited for high school students. So in the coding gravity module, students learn about our ever-developing understanding of the gravitational force, and they explore the role of a simulation and how it can be a part of that process, and they help develop their own gravity simulation. So in doing so, they will learn the basic concepts of programming with JavaScript while investigating what properties affect the gravitational pull between the 2 planets. So here's an example in the bottom left of the simulation that they'll be building, which kind of demonstrates how these planets are going to interact with each other in outer space. And students will be able to actually test the different properties and kind of narrow in on which properties actually affect this interaction. And the modeling mechanical energy module is similar to that previous one, where students will take part in developing different models and scenarios where they can investigate what influences the amount of kinetic and potential energy an object possesses. Students will get to experience some basic programming in JavaScript and see how it can be useful in something like physics. So here are 2 scenarios, again, that students will be working with to understand how those kinetic and potential energies shift over time and location. But there's going to be a kind of variety of opportunities to explore with these scenarios. And another neat aspect of this module and the gravity module is that students will actually be able to do some coding to print live data and then use those numbers to help support their observations. So it might be students are observing how a kinetic energy is changing as this ball is rolling, but then they could actually print the kinetic energy and be able to look at that data to be able to support that. Because I know that's a big part of the NGSS standards to use both that simulation and data piece to that. Cool. So those are the new modules. We can talk about now how to access them. So at this point, we've set up 2 beta sections, which you're able to enroll in and experience the course as a student. So you'll have access to all the student-facing material and then the full course that you can use with your teachers will be released later this summer, which I'll talk about in a moment. To join these betas, it's similar for both course. We have a join link here. So it's codehs.com/coding_math/start. And then you will be prompted to put in a class code And I believe Rachel potentially is adding these to the chat. She's on top of it. So again, that will enroll you into the course, so you'll see the student-facing content. One thing to note is that the videos aren't recorded at the moment or included in the moment. So you'll see the slides and the speaker notes, but upon the full release, these modules will have videos too. That's, I think, the only student-facing thing that's not a part of the betas at the moment. Also, we have some information about these courses, a lot of which I've talked through here. So the course overview page, every course has an overview. So this can be found through our course catalog if you look up coding and math, but the URL we'll put in the chat as well. And I'll actually pull up this overview so you can see what's on here. So you get a description of the course. You can actually enroll in the beta through here as well. I'll show you the syllabus in a moment, but here's the modules that are included and a description. This also is showing you middle school, high school, and about how many hours we estimate it might take. Of course, this is depending on what class they're in and their experience coming into this, that's going to range. Yeah, could go longer or shorter. And then we have some demos of items in the course and some resources, an example lesson plan and handouts that are in the triangles, categorizing triangles module. And just to look at the syllabus really quick here. So syllabus has a lot of information, kind of an overview of the course, but then it has the module breakdown as well. And so this includes the description. And then I went through and listed the main concepts, both in the interdisciplinary, so math, and the computer science, and then the grade and the approximate number of hours. So hopefully this may help as you're thinking about how you might include this as part of a unit you're doing on specific math topics. So yeah, and we have a direct URL to the syllabus as well. So codehs.com/syllabus/13419, which is the course code there. Cool, and then the same thing for the science. So as you could probably guess, if you want to sign up for the science beta, it's codehs.com/coding_science/start. And then we have a class code that will put you in there. And likewise, there is an overview page for the science. It has similar information, so I won't get into it. And also it has a syllabus with the topic and age and hour breakdown as well. So that's all the same there. So I think the question probably many of you have is, when will these actually be available to use with students? And that will be July 30th. So the end of July, that's when most of our courses, if not all, are being released. So that means you would be able to create a section with these courses and then assign modules to students and all of the teacher resources. So like lesson plans, handouts, solution guides, that sort of stuff will be ready for you on July 30th. And the last piece here, because this is a beta release, we have a lot of opportunities to get feedback from you guys. So these modules are completely new material, and we want to be sure that we're providing you materials that are effective, informative, and fun. So we love to connect with teachers that expect to use this course with students and hear from you. And we understand commitment levels are going to vary and timeframes vary. So depending on your situation, we have a few ways to be involved if you're interested in. So within the course, there are surveys at the end of each lesson. Within the beta sections, as you're working through it as a student, each lesson has these surveys that you can provide your thoughts and feedback on the lessons, which again is super helpful. And then we also have the ability, if you want, to be able to leave feedback on individual items, so kind of go a level deeper, then we can get you a part of that group. And then we kind of have a final level if you really want to be involved, and we appreciate anyone who's interested. You can be part of a group that will hop on a call and a couple of times and be able to discuss both with me and Rachel and whoever else is involved, just how it's going. And I know as a teacher, like, you guys have the best sense of what's going to work in the classes. And so hearing from you is super important, and any feedback that you guys are willing to share and provide, that will both influence, the final release in July and any future develop we do with these interdisciplinary type modules. So please consider it. Again, there's a variety of ways to leave feedback, and yeah, I look forward to being able to hear from you guys. So if you're interested at all, if you go to this URL, again, one for each course, coding_math/testing or coding_science/testing. And that's just a survey to fill out, give us your information, kind of list what level you'd be interested in giving feedback. And then we will reach out to you and yeah, get you set up. So again, it's super meaningful for us. I think the betas have two purposes. One, to get it out there so you guys can start getting a sense and do some planning, but then also so that we can refine these and make them as effective as possible.